Hello everyone, I am MS Bhagavati Ammal, Assistant Professor of Computer Science and Engineering Department, Rohini College of Engineering and Technology. Our subject code is CS8691 and our subject title is Artificial Intelligence. In Unit 5, we are going to discuss about the topic is robotics. Robots are physical agents that perform tasks by manipulating the physical world. To do so, they are equipped with effectors. The effectors such as leg, wheel, joint, and grippers. Then robots are equipped with sensors which allow them to perceive their environment, including cameras and lasers to measure the environment, and gyroscope and accelerometers to measure the robot's own motions. Then most of today robots fall into one of three primary categories. The main categories are manipulator or robot arms, mobile robots, and mobile manipulator. Then manipulators are robot arms physically anchored to their workplace in a factory assembly line. Manipulator motion usually involves a chain of controllable joints enabling robots to place effector in any position within workplace. Then mobile robots move in their environment using wheels, leg, or similar mechanisms. They have been put to use delivering food in hospital, moving container at loading door, and similar tasks. Then unmanned ground vehicles drive autonomously on streets, highway, and off road. The planetary rover explores planets. Then mobile manipulators such as humanoid robots mimic the human. They look and act like human. Then limitation of robotics. Real robot must cope with environments that are partially observable and stochastic, dynamic and continuous. Many robot environments are sequential and multi-agent. Robot cameras cannot see around corners and most commands are subject to uncertainty due to gear slipping, friction, etc. The real world stubbornly refuses to operate faster than real time. In a simulated environment, it is possible to use simple algorithm to learn in a few CPU hours from millions of trials. In a real world environment, it might take years to run this trial. Then, furthermore, real crashes really hurt, unlike stimulator ones. The practical robotic systems need to embody prior knowledge about the robot, its physical environment, and the tasks that the robot will perform, so that the robot can learn quickly and perform safely. Then, robot hardware, the agent architecture consists of sensors, effectors, and processors. Sensor that is represented as a perceptual interface between robot and environment. There are two main sensors, that is passive sensor and active sensor. Then passive sensors such as cameras are true observer of the environment. That means the passive sensor fully observe the whole environment. They capture signal that are generated by other sources in the environments. Active sensors such as sonar send energy into the environment. Rangefinder sensor that measure the distance to nearby object. Location sensor CPS measures location with satellite. Then imaging sensor providing us with images of the environment using computer vision technique. Then proprioceptive and sensor inform robot of its own motion. Force sensors or torque sensors handle track lab object whose exact shape and location is unknown. Then effector help robots to move and change the shape of their bodies. We count 1 degree of freedom for each independent direction of its effectors can move. Differential drive, then synchronization drive, dynamically stable legged robots have been made to walk, run, etc. Statically stable means without moving its leg. Then here I given one image. That image is represented as the Stanford manipulator with 6 degrees of freedom. Here the A part is mentioned as motion of non-holonomic four-wheeled vehicle with front wheel steering, that is by B. Then A is Stanford manipulator with 6 degree of freedom. Here we mentioned 6 degrees of freedom created by 5 revolute joints, and a car has 3 effective degrees of freedom but 2 controllable degrees of freedom. Holonomic robots are easier to control. Holonomic robots are mechanically more complex. We say a robot is non-holonomic if it has more effective DOFs than controllable DOFs and holonomic. Then holonomic robots are easier to controllable. The differential drive robot possesses two independently activated wheels that are trucks. Then one on each side as in a military tank. If both wheels move at the same velocity, means the robot moves on a straight line. If they move in opposite direction, means the robot turns on the spot. An alternative is the synchrono drive. Thank you, students.